We've seen various arithmetic operators, and we've seen the assignment operator, but there's a whole other class of operators that combine the assignment operator with various other operators, and this combination enables what's known as augmented assignment. And this doesn't provide any new functionality, but rather it's a shorthand that programmers frequently use, so it helps to be familiar with it. But before getting to that, let's stick to some things that we've already seen. Let's just assign the value 2 to x, and a very common construct is to increment a variable. Let's say we want to get a new value of x. It's based on the old value, and it's just 1 plus the old value. So now x is equal to 3. Or we might want to update x with a scaled version of x. So we might take the old value, multiply it by, let's give an expression here, 17 plus maybe 492 divided by 3. Okay, so that number within parentheses will multiply the old value, and that will be assigned back to x. And so the new value of x is 543.0. It became a float because we used regular division, and that yields a float. Those expressions above where we update the value of x, in general they look like an L value to the left of the assignment operator, and then to the right we have that same identifier again. So that yields the old value of the L value. And then that's followed by some operator, either addition or multiplication, and then beyond that we have an expression. And in the first case we had an L value of x. On the right hand side we had x again, so that yields the old value, then plus 1, and so the expression was just the literal 1. And recall that literals are the simplest form of expression we have. Now when it comes to writing this using augmented assignment, what we write is, just like before, the L value to the left of the operator, but now, rather strangely, the operator comes next, then the assignment operator, and then the expression. Okay, so this looks perhaps rather confusing, and it will look strange the first couple times you see it, but it is a handy shorthand. So let's go back and set x is equal to 2 like before. If we are going to increment x by 1, what we can write using augmented assignment is plus. That's the operator, the assignment operator, and then whatever we want to add to it, say 1. This is equivalent to x is equal to x plus 1. Now when we look at x, it's equal to 3. That other expression that we had up above where we scaled x by a value, well, there the arithmetic operator was multiplication, so we write that next, then the equal sign, and then we can write 17 plus 492 divided by 3. And in this case, the entire right-hand side is evaluated before scaling the value of x. So we don't need the parentheses here, although we certainly could add them in. So this is equivalent to what we had written above. X is equal to x times the expression 17 plus 492 divided by 3. If we leave the parentheses off there, we get a different value. But let's check on the value of x, and it is what we had before. Augmented assignment works with all the arithmetic operators we've seen, not just addition and multiplication. So for example, if x is equal to 3 and we want to square it, we could write x and then the exponentiation operator, the assignment operator, and then 2. This is equivalent to x is equal to x squared. And when we check on x now, sure enough, it's 9. And things can look rather strange. We could have maybe x is equal to 17, and then take x modulo 5 and assign that back to x. So the remainder after we divide 5 into 17, which is the current value of x, should give us 2. So this expression is equivalent to x is equal to x, the current value of x, modulo 5. And sure enough, x is equal to 2. It can take a while to get used to this augmented assignment. You don't have to use it, but experienced programmers will use this quite frequently, and it helps to be familiar with it.